Very good morning to all who joined for this session. And before we dive into this session, let me just introduce our company and also the presenter for this session. So, Testvox is founded in 2017 and it is based on a Dubai. Location is Dubai, and we are providing the services which is related to software testing, which includes crowd testing, automation testing, performance testing, and usability testing, etc. And from the root of startup, we have dynamically moved and we have dynamically updated to an era like with a skilled engineers and also the other department employees as well. So and overall the years we got a chance to work with different clients, that is not only in India but also that is included UAE and the United Kingdom, etc. So coming to the presenter, so I am delighted to introduce Dr. Abbas Ahmed. She's an ISTQB trainer and a software testing expert, and with more than 6 years of experience. So currently he is serving as the CEO of Certilog FZ CEO, a leading software consultancy which is located in Dubai, UAE. And also Dr. Ahmed, he is specialized in delivering high quality solutions in complex domains like IoT and AI. As the president of ISTQB, Ahmed provides a strategic leadership and contributes to groundbreaking research projects in IoT security and AI detection. With PhD in computer science, his deep understanding of model-based testing for IoT web services added a unique perspective. So, a warm welcome, Abbas, and the platform is over to you. Thank you.
Thank you very much, Anjana. Thank you for this introduction. Yes, as Anjana said, I'm here as the president of the UAE ISTQB, speaking a little bit about the best practices for testing web applications. We are going to see how companies all around the world implement their test strategy, how they analyze and design test cases to test web applications. Just to add up a bit about the introduction, Anjana said. So I have been doing software testing for more than 10 years now, and I have been in the past also a professor at the University of Franche-Comté in Besançon, France, before moving to Dubai. Maybe we can start looking. So I will start with a small introduction to the UAE ISTQB. So the UAE ISTQB is the local representative to the ISTQB. The ISTQB stands for International Software Testing Qualification Board, and the UAE ISTQB is the local board. The ISTQB provides, so it has members all around the world, and it provides syllabi presenting the best practices in software testing. We were elected the 67th member of the ISTQB in 2022. It provides syllabus for a lot of testing techniques, principles. You have, maybe you can see it here, all of the certifications that the ISTQB provides. It not only provides certification, but it also provides all the syllabus, all the training materials that you need to read before passing the exam part. So the entry is the Certified Tester Foundation level, where you learn the foundations of software testing. You learn all the correct concepts in order to build up your knowledge about testing. And we will be more in line today with this presentation. We are more going towards test automation, which is a specialist part of the certification scheme in ISTQB. So it not only provides a test automation engineer, but for example, model-based testing and other certifications. Before starting and talking about how do I create my tests and how do I execute my test and what are the correct best practices to design tests, let's first go back to the principles, like really to the fundamentals. I had a really good question the other day, and I was asked to explain what is a test to small children. How would I explain that? How do I represent a test? I want to really go to the most fundamental part of explaining what is a test in order to understand how to build upon that. So as I have a PhD in model-based testing, I thought to myself, okay, what's the best way other than doing a model? Let's model what is a test at the most abstract level. I started saying, okay, I have a 3-year-old daughter, and I thought she likes Legos, so let's do some boxes. Let's say, okay, I have a test. I will represent it in a box. I will say, this is my test. I will say, okay, what do I need more to represent in this model? So a test is going to test something, which is our system under test. I'm going to call it SUT for system under test. And why I am saying system under test? Because we are not just testing software. So it can be also software as under test. But we are not just testing software. Most of the time we are testing systems, which is, for example, an application who is connected to another application, and we have a system of systems. It can be also something physical, like a hardware, like a connected car, like a connected fridge, anything which is part hardware, part software. For example, the ATM machine that you go to withdraw some money or to put some money, it has a hardware part and a software part, so we call it a system. And of course, our test will need to perform some actions on the SUT. So we have a part where we are going to have to bring an input to the system, and we want to read the output from the system. We want to know what is the state of our system in order to define, did our test pass or fail? So this is another. This is one of the first definitions that I'm going to give. Is the expected result of a test is called test oracle. So from the ISTQB glossary, we call this a test oracle. So the test oracle basically would give us the test result. Is our test a success or fail? So this is what I've come up as a model to represent a test in the most basic form. If you take any part of this model out, you do not have a test anymore. If you take out the expected result, so the test oracle, it's not anymore a test, it's just some functional case. You cannot remove any part of this model and say that you have a test. So this is just so we can have all a common understanding about what is a test. So we said a test will perform some input on the system under test, and this is what we call controllability. So it's not controlling as I am looking what it is doing. I'm controlling is I'm performing some action, whether it be manual control, for example, clicking on buttons, filling up input forms, or it can be a script that is performing those actions. And the output is the observability of our system under test. I want to be able to check what the system, in which state it is. I want to be able to go get some data and know what are the values. And those characteristics are part of characteristic for testability. You need to be able to control and observe your system under test in order to test it. This is really important for all of the people working with web applications. We always have this problem of being able to control or observe the systems that we are testing. For example, whether it be you need an ID on some input to put the text, whether an ID on some button in order to be able to click on it, or any other way in order to control and observe your application. So it's really important that as a tester, you be sure that you have the testability characteristics in order to be able to perform in the most efficient way your tests. Then we define what is a test, what are the testability characteristics of a system under test. And now we want to go look a bit deeper about the test levels. At what level I can test, first of all, what is a test level, and at what level I can test a system under test. The first level, the lowest level, is the component level. So let's imagine a system where I have only 3 components. The components they are code effectively. This is really the lowest level in the system. In the system we are building is just some functions, for example. Of course, a real system will have hundreds, if not thousands, of components working together. It can be a function, for example, to log in, a function to add an item to a cart, for example, a function to send an email. Anyway, all the components of our system need to be tested individually. This is what we call component testing, or you might know it also as unit testing, where we are testing each component individually, and usually this is done by the developers of the components. So the developer will write the code, write the test associated to that code in order to make sure that his component is working individually well. Then those components, you want to integrate them together. So we have the second level of testing, which is integration testing. The components may want to talk to each other. They may want to talk to each other through a network layer. We don't care how. It can be HTTP, it can be Wi-Fi, it can be Bluetooth, it can be a radio frequency. We don't really care. But what is important is when you integrate the components, at the end of the integration testing, you have built a system. And this is your system under test, and you will be able to perform system testing. This is the third level of testing. When you do system testing, you are ensuring from end to end that what you have developed is working correctly. We don't know if this is what the client wants. We are just making sure that what we have developed is actually working as intended. Then, the last level of testing is the acceptance testing, and this is where we make sure that the software or the system under test responds to the client needs at the end. So basically, this is the 4 test levels. You go from component, testing the components of a test individually. You integrate them together. We're going to do integration testing. This is where also a tester is involved in putting in place all the continuous integration mechanism. And when you have your system built, you can do system testing to make sure what you have built is working correctly. And at the end, you make sure that your system responds to the client needs, and it is called acceptance testing. Those are test levels, and for the test level, you will be able to apply a lot of test types. So you have, this is by far not all the test types that exist. So in this graphic, I have some of the test types. You can do smoke testing, unit testing, regression testing, API, security, performance, any way. So this is, you can do all the test types. Some of the test types will cover all the testing levels that we have seen. Other will only be able to be applied on one or two test levels, but it doesn't matter for us. Another definition that I want to introduce in this presentation is the abstraction level of a test case. So we have defined what is a test. We have seen that a test needs can be from any test level. So you can have a test to test component, integration, system, acceptance. It can be of any type. It can be security test. It can be a performance test. But it also, a test case have an abstraction level. This is really important to understand, because it will define on what techniques, test techniques we can use in order to fulfill our test objectives. So what is an abstract test case, and what is a concrete test case? So you have levels of abstraction. The lowest level of abstraction, it's basically concrete test cases. So this is where you are going to have to use values for test data, where you're going to have a detailed test design. So I will show you an example just after the slide, just after explaining what is the highest level of abstraction level. And this is where you are going to use, for example, equivalence partitioning in order to explain what data you are using. And you are going also to have abstract test cases where you don't have really concrete step-by-step explanation of what you're doing. So it's really important to know where you want to be, and I will explain how you can choose on which abstraction level you are going to develop your test cases for your web application. So let's first look at an example of a concrete test case. I have this application, which is a login form, where I can put my username, my password, and click on the button login to log in. If I am testing it as a concrete test case, so the lowest level of abstraction, I would be defining my test data. For example, I would say I have a username, which is testuser@test.com. I have a password, admin123. Please don't use password like that. This is just an example, okay? Don't ever use passwords like admin123. The test case which I'm going to build is a concrete test case, so I will have steps. So if you remember, when I defined the test case, I said that we need some input, some output in order to define the results. So this is what I need. Actually, I have a test case with 3 steps where I'm going to input the username, the password, and say I want to click on the button login. And I have the results. So the username input is filled. Here is the password. I made a mistake. And at the end, the user is logged in. So I will have also a lot of test cases. It will go on. So this is the lowest abstraction level. I have hard-coded data. I have detailed steps for each test case. And if we go see what a high-level abstraction test case is, we are going, for example, to use equivalence partitioning, where my test data will not be anymore a username and a password. It will be more like my test data would be valid, invalid username, valid, invalid password. The test cases will look more like of scenarios. For example, log in with a valid username and a password, log in with a valid username and an invalid password. It would be more high level. That's what we mean by the abstraction level. So this is for defining what is an abstract or a concrete test, and we can create test cases manually, or we can create test cases for automated execution, for manual or automated execution. Manual execution is more in line with experience-based when we are, of course, speaking about test design. So it's more in line with experience-based. And automation, we are going to use automation tools, of course, in order to execute the test. For experience-based, if you have a high experience and you have domain knowledge, you will use abstract test cases. You will go more for the test cases which look like this: log in with a valid username and a password. If you know what you are testing and you have experience building tests, it's more logical to go with abstract test cases, because you don't need to detail everything. It will not make sense. It will just slow you down. If you are a new tester, you don't have a lot of experience, you don't have a lot of domain knowledge, you will want more to design concrete test cases. Give for each test case, give each step with each result you should have, in order to guide the tester in his manual execution of the tests. As for manual test design, so I don't know if you'd be surprised, but one of the most used tools to design test cases for manual execution actually is the Office suite. With, of course, the most used tool, which is Excel. This is really one of the most used tools in order to design test cases worldwide. Really, everywhere I have been, I have seen some sort of Excel being used in order to define the test cases, the steps. You can see them again, the description of the test, the status for the execution, and of course the expected result and what is the actual result, and if you can add some comments. So there are variations of what the data you use, what data you collect, but the Microsoft Office suite is really one of the most used for now. People use Outlook and other to send test reports. They use PowerPoint to make test reports, Word also. You also, of course, you have other tools which enable to enhance the collaboration between the testers. For example, I take an example of X-Ray Jira. It's basically the same, really. If you go back to the fundamentals, if you go back to the basics, you will have the same data as you are doing an Excel sheet or a Word sheet. You have the exact same data you have for each test case. You have the actions, you have the data that you are going to use, the expected result, and what is the actual result. It's just another way to present the data. It's another way to collaborate more easily. It's more easy to put a lot of testers in a test manager tool to collaborate together. And of course, I give you one example of test management tool, but you have really a lot of tools which have been developed to assist manual testing, design, and execution. And there are some more, of course. Maybe, yeah. For example, I take an example of the latest test management tool I have used. His name is Squash, which is a French tool, which is not in this list. So let's get back to our test design. We have seen globally for manual testing, and now we want to go look a bit about how to develop, how to design test cases for an automated execution. So for automated execution, it's a bit more complex, or you have a bit more nuance, because it will depend really a lot on the abstraction level that you are going to implement in your project. It goes like that. You have scripting techniques where you have from the lowest abstraction level, which we have already defined, to the most abstract the scripting technique. It goes from record playback tools to linear scripting to structured scripting, data-driven testing, and at last the most abstract is the keyword-driven testing technique. So let's have a bit. Let's see in a bit more details each scripting techniques for automated execution. For the record playback, maybe you have already heard about Selenium IDE, which is a browser extension. You have another one, which is Catalan Recorder, and you have others. Nowadays, maybe I know that Chrome and Firefox have included record and playback tools, which comes with the browser. One of the pros is that it's easy to install. It's really easy to use. The cons is that it's really vulnerable to the change in your SUT, because you are just recording an action on the application, and if a button is located somewhere and it changes, your test is no longer valid. It's really difficult to maintain. Each time you have an evolution in your system under test, you will have to go back to your system under test and record again the test. And one of the biggest disadvantages of the record playback tools is that it does not enable you to test really early or to start building your test, because you have to have the system under test available in order to record your test on that. So this is an example of Selenium IDE. What you can have, it's actually a plugin which opens a window where you're going to record. For example, here I recorded some steps on the sourcedemo.com website where I did a login. It will record all the actions that you do on the window. For example, click on somewhere in the website, you're going to type a string of characters inside an input text, and then at the end, so after opening, at the end I close my browser, and if I press play, it will play back. That's it recorded my actions. If I press play, it will play back. It will do the actions that I have performed again. This test can be, of course, exported to a test script. Here I have chosen to export the test in Python, but you can also choose any other language. It can be Ruby, it can be Java, it can be really, you have a lot of options in order to export your test case. Then, after seeing record and playback, we go to linear scripting. So linear scripting is actually really, really similar to capture playback, and usually it comes from capture playback. We are going to take the same script, we are going to modify it in order to have it be a bit more maintainable. One of the pros is that you don't really need a lot of things, so you can just record a test case on a system under test, and you will be able to have some linear scripts. You don't need really a lot of technical skills. You need to be able to read a little bit of code, but you don't need to actually code anything. So the cons is what we have talked about. You do not capitalize on anything that you have created before, and for people which are not technical, the generated scripts can be a bit difficult to understand. So what does it look like if I take the same script that I have generated before in Python? When we are doing linear scripting, so it's just adding a bit of commentary, a bit of comments, adding some checks, assertions, in order to check. For example, here I check if when I open my web browser on this URL, I want to be sure that I am on the correct URL. That's an example. Always remember that automating tests, basically it's having a software which is testing another software. So whatever you do, you can use no-code options like Selenium IDE or tools that you don't really need to code, but if you want to go further, you will need to know how to script in some form. You need to understand the code because it's a software which tests another software in any way. So going in a bit higher abstraction level, in structured scripting, the difference from linear scripting is that now we are building libraries. We want to be able to go and take the common actions, for example, login. If I am logging in many test cases, I don't want to have in all my test cases a copy paste of those sequence of actions inside all my tests. I will be able to make a library. So one of the advantages is that I have a lower maintenance cost. I will explain that a little bit further in the next slide. One of the cons is that you have a higher initial cost because you will need now to factorize your code. So you need to refactor your code. You need to create the methods. You need to add some efforts in order to parameterize them. And if it is well executed, it will pay for itself because you are reusing the same code again and again. So, and one of the biggest also problems. So you need technical skills because now you are not just commenting some code or adding small assertions. Now you are really refactoring. You need to understand what is a method, what is a function, how you can call this function, how you can do the right imports, using the right libraries. You need the technical skills. This is an example, so I wanted to change a little bit from the Python example. I'm giving you a Java example here of a function which tests the login form of a website. So I have the login test method where I would be able to log in. I can use this login test method in a lot of test cases. So this is a library. And if, for example, the login changes, if I am not connecting with the username and password anymore, and now I need to connect with the phone number and a password, I can just change my function which does the login, and it will be reflected in everywhere where I use it. Basically, it's a function. Higher level of abstraction, we get into the data-driven testing. The difference from the structured scripting is that the test data is separated from the scripts we are using. We are not it is for application which demand high data consumption. For example, if I take an example on Amazon website, which is an online e-shop, basically, they have millions and millions and millions of items. It is highly demanded of the test data. They are doing a lot of data-driven testing. The idea here is that a test script, so you have a control script. I will show you how it works, and which will execute as many tests as there are lines in a data file. One of the pros is that we have a reduced cost of adding new tests. Adding a new test is basically just adding a new line to the data file, because you have a script which reads the data file and executes the test. It's accessible to functional testers, people who does not have technical skills to develop the test case. So you still need someone to develop the script to read the data file, to execute the test, but you can give it to non-technical personnel. They can add tests, people who know the business side of things. One of the problems with the data-driven testing is the maintenance of data files. They can grow really big, and most of the time what I have seen, or what we have seen, is people have a tendency to add nominal test cases where everything goes well, and they forget about the negative test cases or the test cases that can make your system crash. Here's the representation of how it works for data-driven testing. For example, if I have an application which relies a lot on data, I have a calculator, online calculator here. This is my web application that I want to test. My data file here is a Microsoft Excel file where I have all the data in order to test my application. For example, the first operator, the action, the second operator, and the result. So my data file is in Excel. What I need to do is I need someone to script, to give me a test script. The script will read the data. It can be Excel, text, CSV, it doesn't matter. It will read the data and then execute the test on my application. We don't care about how many test cases there are. I have a script which will read it. If I want to add a new test, for example, I have someone from the business come say, "Oh, I want to test 4 divided by 0." So he can add. You don't need technical skills in order to add a new test case. It's just adding a new row to the data file. We said that one of the cons of this testing technique is that the test data can grow really fast. So here it's easy to understand when you have only 6 test cases, 5 test cases, but if you have 500, 600, 700, maintaining the data file can be quite challenging on the long run. And of course, so I give you an example of with Microsoft Excel and text or CSV, your test script can go grab the data anywhere it is. So it can be a database. We don't care which database. As long as you have access to the data, you read it, you use it to execute your test. Lastly, keyword-driven testing, which is the highest abstraction level in order to test, in order to create test cases. And this is what I like doing the most. It's keyword-driven testing, because one of the biggest advantages of keyword-driven testing is that it's the highest level, so you have the lowest maintenance cost of your test cases. And one of the biggest advantages is that you separate the implementation from the design of the test. So you have a test where you need to design the test case, and then you have to implement the test case. And you really have a clear separation of those two steps, as I will show you. Some functional tester will be able to write, because keyword-driven testing is basically using natural language in order to create tests. And you have people with more technical knowledge who will implement those test cases. One of the disadvantages that it's not really suitable for small application because it will cost you a lot to implement the keywords. I will show you what I mean by implementation of keywords, and it will require a lot of work from your test automation engineers. You have a lot of tools for keyword-driven testing. Cucumber, maybe you know them. Robot Framework is one of the most known. Catalan, Cypress, Test Complete, and others. You have a lot of tools which do keyword-driven testing. Maybe I can take 5 minutes to show you really quickly Robot Framework demo, which I have prepared. I'm going to test. I think you can see the screen. Yeah. So this is my application, which I am testing. It's a demo application where I can log in. So you have some usernames, password. I can put my username, my password, log in, and I have access to an eShop. And I can log out by clicking on the 3 dots here and putting some logout. Okay. Basically, that's the test I'm going to build with my Robot Framework. So first of all, I define a new test case where I call it login. We'll log in, and I am writing the actions that I am doing on the system under test. For example, open an application on Firefox, log into the application with, log out, and close the application. Basically, I'm designing the test case using natural language. This is English. Anyone can write test case, anyone with domain knowledge, of course. He knows what he wants to do. Anyone with domain knowledge can write those test cases, and you can have a lot of test cases really quickly. But now we need to implement. What does it mean? Open the application on or with Firefox. So I can change it to with Firefox. Now it's telling me that this is not implemented. So I need to go and ask the test automation engineer to implement those actions, what it means to do that. So for that, I'm using a Selenium library in order to execute the actions, where I'm going to say, okay, I want open the application with, so it's not on anymore, it's with. It means opening the browser and making sure that I am on a correct URL. Then I want to log in to the application with some data. So I'm going to check the implementation, log in to the application with, I have some arguments, which is a username and a password. And I will do some actions on the system under test, which is I am inputting text of the username, the password, and then clicking the login button. This is what login to the application with keyword is translated to. At the end, I want to log out and close the application, which is closing the browser. I can execute this test again to make sure that it's working. Hopefully. So it opens the browser, it puts standard user, the password, it logs in, and it logs out. And at the end, it closes the application. So you really have a separation of defining the test case, designing the test case from its implementation. What is good is that I don't need to know how to code in order to define new test cases. For example, let's create a new test case, which is login with invalid password. Here, I am logging in with an invalid password, so it's not secret test. So I will say invalid password, and I will be able to execute this again. I did not need to create or to implement any Selenium. This is the test automation engineer who is doing the implementation. So now it will try to log in, and the test will fail, of course, because the password is invalid, and it is saying to me that it cannot log out because I did not log in. So maybe I need to change a little bit this. So this is my last point for this presentation, is to tell you what. So one of the 7 testing principles is that software testing is context dependent. The best solution on what abstraction level you are going to use really depend on the solution that fits the best your context. If you are in a position where you say, okay, I only have 3 weeks, I need to automate, I need to run all those tests, maybe you are going to use capture playback, record playback. If you have a project where you say, okay, I have 1 year, I have some budget at the start, I need to lower my budget after 6 months, so I need my maintenance cost to be really low, maybe you are going to go higher in abstraction when you are designing your test cases, whether it be manual or automated tests. The idea is, the higher the abstraction is, the higher the initial costs are. So you have to pay for the tools, you have to train your people, you have to implement the test scripts. The cost will be really high at the start, but on the long run, the maintenance cost will be lower. You will be having a more efficient way of testing. You will improve the quality of your software. And of course, the execution of creating new tests will be much faster than with lower abstraction methods. That's it for me. Thank you for listening.